It is time to craft an interpreter. Following Crafting Interpreters by Robert Nystrom. Now, this book, I guess it is a book, but I'm going to be reading it as an online guide, right? So not your typical book. Which is kind of cool, actually, how it's available as both a book and also in a digital format that isn't like pages. You know, like it's a pageless website format, which I think is cool. You'll see what I mean in a second. I've been wanting to do this for a while. The reason I haven't is because I've been busy with uni work, but I've just finished uni, so I can now literally just read it. This is clickable. Aw. Damn. Okay. Yeah, so this is thingy. Interpreters. So to give you a bit of background about myself, I have implemented a calculator in both Haskell and OCaml. Haskell one was fairly primitive. The OCaml one had more features like variable shit and stuff. And I think, well, all of this was building up to finally making a full language, making a programming language in Rust was my goal. Although I'm open to other languages. I think this one will probably be using C++, but maybe it applies to any language, in which case I can use Rust. In fact, even if it does use C++, I'll probably just try doing it in Rust anyway. Because it's not too hard to like transfer the concepts, I don't think. Anyway, by the way, just to say, this looks really cool. Like the way like this is actually just the way the fucking like thing is presented looks really cool, and makes it a lot more attractive as someone who is looking to learn this thing. So I think I'm gonna have to move myself over to this side first of all. Mind you, I will be coding, will I? Yeah, maybe not then. I'll sort out my camera later. But yep. So this is different from crafting a compiler because it'll be an interpreted language, right? It'll be a scripting language. So it'll be interpreted on the fly, which means there won't be things like code optimization, or at least not so much. But that's okay, because I think what I will do is I'll first make a scripting language, right? An interpreted language, like Python or JavaScript. Those are scripting languages. Or Lua, I guess, is another example. And then my next step will be making, I think, a virtual machine, like the JVM. I think it's called a virtual machine. Yeah. So like the JVM bytecode is when you compile a language not to machine instructions, but to an intermediate format, where you then have some software called a VM that runs the bytecode. And you could say it interprets the bytecode in a way, but like the main benefit over machine code is that it's cross-platform. It'll work for anything, and all you need to have is the JVM or the VM. Sorry, JVM is a Java virtual machine, so that's what comes to mind. So that'd be cool as well to see how that works. And then the final step would be machine code, compiling to machine code. And I mean, with that, I could just hook up to the LLVM IR, in which case I'm not actually doing any optimization or machine instructions myself. But if I wanted to, I could theoretically write my own assembler? Is that the word? Like write my own compiler to compile my language to assembly, which would be kind of cool. I can't lie. Definitely wouldn't do it like on a large scale, but like just like a small thing. Because something else that I want to do, a project I have on my list of things to do, is a disassembler, which takes assembly and converts it to some other language like C, whatever. So that'd be cool. So maybe I'll do the disassembler first and then also try compiling machine, or maybe the other way around, I don't know. But anyway, the first step is writing a scripting language, and that is what we're doing here. So ever wanted to make your own programming language, or wondered how they were designed and built? Ha! That's me. Then this book is for you. So cool. But yeah, here's a book. It is available as an actual print, and you can see there's a sample here for the PDF. This is, I guess, garbage collection. It does actually talk about bytecode virtual machines here, so I wonder how deep it gets. Because as you can see here, in this image, you have the source code, right, which is like your text file. Then you have the high-level language, so like C++, C, Java, whatever. Your bytecodes, which is that step for like JavaScript, C#, they would compile to bytecode, typically. And the machine code would be like your compiled languages like Rust and C++ and C and all that. So when it talks about interpreters, I wonder if it will also go over bytecode and machine code. I mean, clearly it goes over bytecode, but I wonder if it will show you how to implement machine code. That is quite interesting. But that's the book there. If you look at UK, Amazon. Yeah. Actually, I wonder if it's in my library. Let me have a look real quick. I mean, this isn't really important because I want to read it anyway online, but I'm curious. University of Liverpool, library. Have a search. It's available online, but not in person. Like as a physical copy. Okay, but there's an ebook there. There's a PDF here, but you know what? There's a web version which is completely free, which is awesome. Every chapter, aside, and illustration is there. Read the whole book for free. Really, I think that's awesome that he has that as an option. So Robert Nystrom, you're very cool. He works on Dart. Hold on, we have a detour here. Dart is a language I've heard of, although I've never actually looked into it that much. I don't know what it really does. Like, is it general purpose or not? It seems to be general purpose, because it's comparing itself to Kotlin, Swift, and TypeScript. It's by Google. I wonder why it's comparing itself to Kotlin, Swift, and TypeScript in specifically. I guess because it's probably garbage collected. So it wouldn't compare itself to like Rust or Zig and all that. Class, so it is object oriented. Class segment, or at least I assume it is. Int links equals 4, so it goes C style syntax there. Oh dear. And then to string, I have links. Override function to string, public var description. These between anonymous functions. Interesting. But he's working on this language, which is cool. The language bug. A number of hobby languages. So 4? Is that what he's saying with these individual links? And I know it's hard to see my highlighting, but each of these has their own link. He made Ren, Smalltalk in a Lua sized package with classes. That's cool. Magpie. I guess he's a fan of birds. Looks like kind of Python-like. Patterns, classes, and multi-methods. Ruby. Interesting. I haven't looked at Ruby, but it is a language I want to look into at some point. Particularly for web development, there's a course I can take. It's called the Odin Project, and they have Ruby and Ruby on Rails. So maybe I can learn it there. Finch. Okay, these are all named after birds, if I'm not mistaken. Finch is still very early in development. Huh. This one's bytecode interpreted. Object-oriented, inspired by Smalltalk, self and JavaScript, written in C++. He wants it to be an example of a small, clean code base for an interpreter. That's cool. So, maybe it'd be worth looking at this to see a good example of a language implementation. Create an object. Trace is a method for outputting the series of left and right turns. Have a quick look. This link isn't clickable, but it's a public archive, so he's stopped development. Oh yeah, clearly. Okay. It's quite old actually. 15 years ago, for the oldest commit, right? Or like the oldest visible commit I can see here. Interesting. So this is so this would be on like C++ fucking 17. Assuming he updated it. Otherwise it'd be C++ 11, which is really old. So that would be quite interesting to see. This one goes back as 17 years ago. So that's like what, 2009, pre C++ 11, which would be even more like crazy to use. Using C string. Yeah, using C headers here. Very interesting indeed. Compiler, interpreter. So I suppose you can write a language that can both both be interpreted and compiled, where the compiled version is just like more optimized. I don't know what that would do for like syntax, because like I mean scripting languages like are scripting languages single pass? They must be, right? Unless like they pass over and then go back through again. Multipass. That's right. Python actually does compile to bytecode, or it can do anyway. In which case it can be a multipass. But like if you're just loading a script, surely that's single pass. Unless you like scan the whole thing for some quick information and then use that to your advantage maybe. But that's interesting. But like because like single pass compilation has its limitations. It's why C++ has issues with like how you have to order things, even though C++ is now multipass. Like because of how the compiler was originally developed, if I understand this correctly, you can't simply like, for example, like you have to forward declare a class if you have two classes that reference each other in the same file. You have to forward declare one of them before the other. So stuff like that is interesting. I'll have a quick look at the interpreter code. I mean, obviously this wouldn't still be, I mean, like this is like 15 years old, so this wouldn't be a, you know, a, what's the word? Like a, what's the word? Role model? Oh my god, bruh. Yeah, this wouldn't be a good exemplar of modern C++ and how you do it in that language, but to be fair, you wouldn't use C++ anyway. Okay. And we have Visual, the eternally morally vigilant programming language. Is this one purely designed and not implemented? Swear result is greater or equal to 0. Interesting. Okay. Anyway, this is a bit about Robert. Whoa. Okay, he works at EA. I wonder if he ever did anything in Plants vs Zombies. Just what comes to mind when I hear EA. He wrote this book, Game Programming Patterns. Interesting. Is it also available as a web? It is. Holy goat. I probably wouldn't read this because I'm not like well, yeah, like I'm not like crazy about game development right now, but very cool indeed. He's got a blog which I would definitely look at. It's on Twitter. I mean, I don't know how old this website is, so I don't know if he still is, but it's on Blue Sky now. And Mastodon. Damn, 51,000 followers on Mastodon. And he does post there. I do wonder about using Mastodon. I feel like it's a better alternative to Blue Sky, to Twitter than Blue Sky is, just because it's well, if you look at my sidebar here, I have Mastodon built into my browser, and I think it's more popular amongst programmers. I might be wrong though. This is a boot.dev, but yeah, I'll have a look at Mastodon at some point. And this is his blog. AI psychology. Have a look at his archive. crafting interpreters. That'd be cool to see. I'll bookmark this. Keep in mind. Debugging C# versus C++ performance. Cool. Yeah, people tend to think that like Java and C# is strictly slower than like C, C++, but they can actually get decently close. In fact, it's possible to run C# without garbage collection, but it's not particularly nice. But like, even with garbage collection, it can be designed in such a way that nowadays it actually is quite fast. Not that I like garbage collection, still. I think it's a compromise that doesn't need to be compromised. And so I see it as like a temporary solution, kind of, and that as soon as a language that comes along that makes memory management safe and easy, without need for garbage collection, then, well, garbage collection languages will just kind of die out and be replaced by those ones, which is why I'm so excited to see the development of languages like Rust and Zig and Odin and C3 and all that. Anyway, crafting interpreters. Let's go straight in. Enough for dilly-daddling. So, if my camera covers anything, I'll move my fat head, but until then, this may be the beginning of a grand adventure. Let me just zoom in here. Oh. Okay, that actually hides the bar. I guess that's actually not too bad. Okay, I'll do that then. Right. This would be the beginning of a grand adventure. I should also be taking notes while I do this. So let me also open Obsidian and get this ready. Now, I don't mind having monolithic source notes, I don't think. So I'll just call this a book. And if I need to split it up later, I'll do that. So for now, I'll just do the whole thing. Crafting interpreters by... Oh, cool. I can also see this here. By who? Robert Nystrom. Or Nystrom. Is it Nystrom or Nystrom? I assume Nystrom. It's quite an unusual name. Robert Nystrom. Ba-ba-bam. It's a bit of boilerplates. Interpreters. Robert Nystrom. Published. I don't fucking know. I mean, it's published like every... I assume this gets frequent updates. And like it's not just like a one and done. But if I check the most recent book release, it says 2021. So I'll go with that date. 28th of... Okay, buddy. Bro, I need to get used to using my own keybinds. It's actually insane. I just close Obsidian. Let's get it back. What was I? 28th of July 2021 was the latest edition, apparently. It is a... Ooh, is it a book? I mean, it's a book, but it's like a web book. But I guess it doesn't really matter, does it? I'll call it a book. Because it has like chapters and stuff, so it's a book in spirit. I have a link to this website. And a preview. I guess I'll just steal one of Google Images. Make sure to misspell interpreters horrifically. Actually, this is a good preview. The Rust programming language. What's that fucking hammer? That's a cool image. I haven't read the Rust programming language. I probably won't. I care more about like the philosophy behind these things, which is why I seek to read books like that. In fact, I have Bjarne's book on C++ and its development. I am meaning to read that, and I will at some point. Because like I can read, like I got like the C++ book to like read about the language, but at like the end of the day, you just learn on the fly, really. I don't really care to read like every intricate detail, and even Bjarne in his book says like, don't read this back to front, like just read it when as you need it. So for me, I mostly just read the introduction where he like explains his, you know, like the history of C++ and all that, and then after that I kind of just lost interest in reading the rest of the book, which is fine. It's why I don't particularly fancy reading the Rust programming language. I think if I want to read a book like that, or like get like that kind of, like to get what I want from a book like that, I could just look at the Rust blog, right? And same with like Bjarne, like I can look at his like interviews and stuff. But I'm also aware that he releases his books about C++, particularly because he cares about Well, let me just find it real quick. I'll find it somewhere. Publications. I swear he had like an ad for his book at some point. But yeah, this one, The Design and Evolution of C++. Sick. That one is obviously focused on the design, right, of C++, so I do care a lot about that one. Anyway, this may be a beginning of a grand adventure. Programming languages encompass a huge space to explore and play in. Plenty of room for your own creations to share with others or just enjoy yourself. Brilliant computer scientists and software engineers have spent entire careers traversing this land without ever reaching the end. If this book is your first entry into the country, welcome. Is it? No, well, not really. The pages of this book give you a guided tour through some of the worlds of languages. But before we strap on our hiking books and venture out, we should familiarize ourselves with the territory. The chapters in this part introduce you to the basic concepts used by programming languages and how these concepts are organized. Locks. Oh. So we are actually going to be implementing a particular language, which is called locks. And we're doing it twice, apparently. Alright, handcrafted by Robert Nystrom. Copyright from 2015 to 2021. What the hell? The source code of this website's open? It's written in Markdown. That's cool. That's very cool. Right, introduction. So what I'll probably do is use this extension where you can like highlight stuff, and then I'll do that to take notes, at least for now. And then I can put them to Obsidian afterwards. Fairy tales are more than true, not just because they tell us that dragons exist, but because they tell us that dragons can be beaten. Neil Gaiman. Neil Gaiman wrote Coraline? Sorry, just for the record, I'm gonna get fucking what's the word? Derailed quite a few times, but yeah, Neil Gaiman wrote Good Omens as well. That's crazy. Coraline and Good Omens, and The Graveyard Book. I do want to watch Good Omen. 1990? Oh, the book, right? Because I mean, it is David Tennant. So I'm really excited that we're going on this journey together. This is a book on implementing interpreters for programming languages. We do have side notes here, so I'll try not to cover them. It's a book on how to design a language worth implementing. It's a book I wish I'd had when I first started getting into languages, and he'd be writing in his head for nearly a decade. Cool. To my friends and family, sorry I've been so absent-minded. Haha. In these pages, we will walk step by step through two complete interpreters. So they're both interpreters, okay. I wonder what separates them then. Your first French languages, so I'll cover each website line of code. Nice, I like a guide that covers everything in depth. Well, like covers everything, well, what's the word? Just covers all bases, basically. In order to cram 2 full implementations and 1 book into a doorstop, this text is lighter on 3 than others, okay. With the lingo, so a cocktail party. Dude, I would love to go to a cocktail party full of a cocktail party full of PL researchers. Alright, we got our first acronym. Strangely enough, situation I found myself multiple times. You know, this I believe. One day, bruh. One day I'll meet such a crowd. But we're mostly going to spend our brain juice getting the language up and running. Theory is important because being able to reason precisely about form of a syntax and is a vital skill. But personally, I learn best by doing. Me too. It's hard for me to wade through paragraphs with abstract concepts and really absorb them. If I've cleared something and debugged it, I get it. Yeah. Systems particularly require rigorous format reasons. Hacking type systems, the same thing as proving a theory mechanisms. Right. Yeah, I've seen lots of like type theory. I don't understand it at all, so I would love a good formal introduction to it, just so I can like properly process it. Unfortunately, I don't think my uni course for computer science goes over programming language design and like type systems and all that, which is unfortunate, but it would be awesome. This is one note, is it? It turns out this is no coincidence. In the early half of last century, Haskell Curry and William Owen Howard showed that they are two sides of the same coin. Ah, yeah. I mean, I know Haskell Curry. I've heard of this, the Curry-Howard correspondence. I don't really understand it though. Like, is it just saying that, yo, code is like maths? Like, is that really what it says? Like, I get what it means on the surface, but like, I don't really get why it has like a special name. Like, just to say that, yo, by the way, programming and maths is similar, but I don't know. I would be interested in learning more about that. Formula, type, proof, term. Formula is true, type is an element, formula is false, not an element. Disjunction is a sum type, conjunction is a product type. Implication is a function type. Huh? A implies B, A produces B. Yeah, I don't know. Although it is cool that people acknowledge the overlap between the two. Yeah, that's my goal for you. I want you to come away with a solid intuition of how real language lives and breathes. My hope is that when you read other more theoretical books later on, okay, so this will really be a good introduction. Jojo's Steelable Run is coming to Anime Expo on the 3rd of July. Sick. I wonder if they'll show anything. Sorry, I just want to start my phone. Why learn this stuff? I don't think ornithology books worry about justifying their existence. They assume the reader loves birds and starts teaching. Okay, so clearly Robert does like birds. Yeah. I like that. But yes, they're different. It is true that they're also creating body successful, blah blah blah, are slim. The designers of this world's languages could fit in a Volkswagen bus, but even without putting the pop top camper up. Yeah, no. I can answer this question personally, which is, well, I mean, the answer is you learn it if you're interested in implementing a language. But the question is, why would you implement a language in the first place? And that's because it's a tool, you know. It's like why would you study maths and try to progress maths? You know, because like they can give us tools that, in fact, it goes beyond maths, because it's more like engineering, right? Software engineering, or it's a type of engineering, because you're creating tools that people can use to create other tools, like the guy who invented the hammer. I don't know why that came to mind of all things. Little languages are everywhere. For every successful general-purpose language, there are 1,000 successful niche ones. We used to call them little languages, but inflation in the jargon economy led to the name domain-specific languages. That's hilarious. Inflation in the jargon economy. These are pigeons tailor-built to a specific task. Think application scripting languages, typically engines, markup formats, and configuration files. Yeah. Yep. It is interesting, actually. I mean, general purpose. Yeah, no. I guess there's a clear distinction. Like, you could argue that every language still has a domain, regardless. And like, even if they claim to be general purpose, they probably specialize particularly well in one field, and get outshone by other languages in a different field. Like C++, it does not thrive in like rapid development and like prototyping. That's why you want a scripting language that's interpreted, because then, you know, it's faster. So, you know, you can call C++ general purpose, but really it's a systems programming language. That's the domain that it's been attributed to, which is interesting. And Rust also wants to be general purpose, but I mean, it definitely isn't going to be as fast as Python when interpreted, that's for sure, with a compiler. So yeah, anyway, it's interesting. I'll make a note on that. Is any language truly general purpose if they still satisfy a particular domain and are outshone in other domains? Right. Honestly, he says inflation in the jargon economy, which is funny, but like, domain specific isn't really jargon. I'd argue it's the opposite. Like, domain specific is very clear, it's specific to a domain. Little language just sounds like a little language. Like what? Like a language that's small? Like Lua? Like, this is the real jargon. Just saying. A random selection of some languages you might run into. Make, XSLT, I don't know that one. Don't know Inform. I do know YAML. Ansler, don't know that. CFML, don't know that. Swig, familiar. IDL, don't know. Emacs Lisp, okay. Jinja, is that a build thing? C++, of course. INI, JSON, VimScript has been sunset, hasn't it? Lex is this language that we're going to be doing. Sed, don't know. Bash, yes. Batch, no. Mustache, what? Awk, what? CSS, HTML, of course. SSH, is that like SSH? I don't know. XML, yep. Yak, don't know. SQL, yep. TCL, no. Like the TV. Bison, no. Guile, no. ASP.NET. I actually don't know a fair few of these. I've never heard of a few fair of these. Yeah, Bash being a programming language is interesting. But it is, right? I guess like just declarative. Almost every large software project needs a handful of these. When you can, it's good to reuse an existing one instead of rolling your own. Yeah, once you factor in documentation, debuggers, editor support, blah blah blah, doing it yourself becomes a tall order. It's true. But there's still a good chance you find yourself needing to whip up a parser or other tool when there isn't an existing library that fits your needs. So this is the why, right? I guess. Languages are great exercise. Long distance runners sometimes train with weights strapped to their ankles or at high altitudes where the atmosphere is thin. When they later unburden themselves, yeah. Yeah, it is a real test of programming skill. This code is complex. The code is complex and performance critical. You must master recursion, dynamic arrays, trees, graphs, and hash tables. Yep. I don't really understand hash tables, so, or like hash maps, so I would love to understand them better. Like really, like learning a fucking programming language is just such a no-brainer to me. At least as someone who's also interested in PL design anyway, and then like actually implementing one, you know, I can get better at programming as well. It is a challenge. Cool. One more reason. The last reason I have for me to admit, because it's so close to my heart. When I first typed out basic programs one key at a time, I couldn't conceive how basic itself was made. Later, the mixture of awe and terror in my college friends' faces when talking about their compilers class was enough to convince me language hackers were a different breed of human. Cool. And as practitioners don't hesitate to play up this image. Two of the seminal texts on programming languages features a dragon and a wizard. Yeah, it is funny how fucking fantasy has made its way into, I guess, programming language. I mean, not fantasy, but like magic. Like you call like a GUI tool to help you, you call it a wizard because like it magically does things. A file signature used to be, and by some is still called magic for some reason. Like, okay, dragons. Yep, LLVM is a dragon too, and Clang. Well, obviously Clang would be because it's the same thing. Ooh, dead link. It's unfortunate. It's a charming image, but it has a darker side. I didn't feel like a wizard, so I was left thinking I like some inborn quality necessary. Sorry. I was left thinking I lacked some inborn quality necessary to join the cabal. By the way, just a note here, I am highly congested, like 24/7, so if I struggle to speak, that is why. Though I've been fascinated by languages ever since I doodled made up words in my school notebook, it took me decades to muster the courage to try to really learn them. Yeah. I mean, this is something I've been trying to get over myself just in general. It's like seeing these things as super complex. How could I possibly understand it? And then just like brick by brick, making an attempt to understand it and approach it in a way that I can digest. And then it demystifies it, you know? And it's cool, because then suddenly you become the wizard. Yeah. So, something I've been trying to do lately in general is approaching things that appear magical and like there's no way I could comprehend them, and then demystifying them. Yep, so like programming language design is a big one for me. Reverse engineering, I'd love to become like a cracked reverse engineer where I can just open anything and fucking understand what the application is doing and hack it and everything. That'd be awesome, wouldn't it? Web development, I know like is something that seems so simple, but to me it also seems like wizardry, you know, with like server stuff and like backends and databases and all that stuff. Like to me it seems very wizardry, you know, it's all very wizard. When I did finally start cobbling together my own little interpreters, I quickly learned that of course there's no magic at all, it's just code. and the people who hack on languages are just people. There are a few techniques you don't often encounter in certain languages, and some parts are a little difficult. Nice. Leave you just a tiny bit braver than you were before. And who knows, maybe you will make the next great language. Yeah, that's me, guys. Okay, how the book is organized. 3 parts. So part 1 is just an introduction. Oh, right, we did see that, to be fair. Yeah. I guess. Locks allows you to be implemented. Each of the other 2 parts builds one complex locks interpreter. Within those parts, each chapter is structured the same way. Okay. So each language is a single language feature, and then it shows you how to implement it. It took a good bit of trial and error on my part, but I managed to carve up the 2 interpreters into chapter-sized chunks that built on the previous chapters, but require nothing from later ones. That's impressive, actually. For the very first chapter, you'll have a working program you can run and play with. With each passing chapter, well, that'd be sick, actually. It grows increasingly full-featured until you eventually have a complete language. Copious, scintillating English prose. Chapters have a few other delightful facts. Scintillating? Jesus Christ. Brilliantly lively, exciting, or clever. Okay. Add that to my vocabulary. The code! We're about crafting interpreters. So this book contains real code. Every single line of code needed is included, and each snippet tells you where to insert it in your ever-growing implementation. Many other language books and language implementations use tools like Lex and Yak. Sorry, ours is called Locks, right? Yeah, never mind. So Lex is different. And Yak, so-called compilers that automatically generate some of the source files for implementation from some higher-level description. Okay, so there are pros and cons to tools like those, and strong opinions. Some might say religious convictions on both sides. Yeah, so I have heard of this where like you just feed a tool a you just feed a tool a grammar, right? A formal grammar, and then it produces a compiler for you, which is cool. Yak is yet another compiler. Okay, you find all these little references and puns charming and fun. You'll fit it right here. I think it's funny. Isn't there another thing like this? Yet another something. Yet another. Huh? Yet another programming. Like it's a joke. But I forgot what like. There's another one I've heard of. Okay, that's cool. I actually want to take a quick peek at this. Does it show like the grammar? Yeah. Okay. A bit. That's cool. So take a note on that. A compiler is a compiler. No, is a tool that takes a formal grammar for a language, for a programming language, and produces a compiler for you for that language, which I think is very cool. Although it kind of takes some of the fun away from doing that. What a cool tool, man! This highlighter thing. Well, so aside from it just taking me down the page like that just now. We will abstain from using them here. I want to ensure there are no dark corners where much confusion can hide. Yeah, of course. We will write everything by hand. Yippee! Book is different constraints from the real world, and so the coding style here will not always reflect the best way to write maintainable production software, especially given the date of this thing. Although I do hope it's good. If I seem a little cavalier about, say, omitting private or declaring global variable, understand I do so to keep the code easier on your eyes. The pages here aren't as wide as your IDE, and every character counts. What does cavalier mean? An attitude, a way of behaving that is dismissive, arrogant, or lacking proper concern for matters that are serious or important. A way of acting that appears to disregard the importance of an issue, let's say. That's cool. Well, I'm getting more fucking new vocabulary from like a book about programming languages than I am about like other things I read day to day. To be fair, it is programming languages, so the people who are interested in that I expect would have quite a good grasp of human language. The pages here aren't as wide. Yeah. Also, the code doesn't have many comments. That's because each handful of lines is surrounded by several paragraphs of honest-to-God prose explaining it. What do you mean, honest to God? When you write a book to accompany your program, you're welcome to omit comments too. Yeah, I generally don't use comments anyway. While the book contains every line of code and teaches what each means, it doesn't describe the machinery needed to comply on an interpreter. Makes sense. So, but like, are we using a particular language, or is he going to use pseudocode? This is Java. Wow, I'm definitely not using that then. So I'll probably have to translate Rust to Java. Java to Rust. Sorry. Yeah, those kind of instructions get outdated quickly. They do. XO Branley, not backyard huge. I don't drink enough or at all to really understand, but let me take that reference. Although I will look it up. Wow, that is oddly specific. So is Robert British then? Since the book contains literally every line of code needed for the implementations, the snippets are quite precise. Also, because I try to keep the program in a runnable state, sometimes you add temporary code that gets replaced in later snippets. A snippet with all the bells and whistles look like this. Logs scan.java, replace one line. Yeah. If it's digit, number, else logs an error. In the center, you have the new code to add. Oh, I see. It may have a few feet outlines above or below, show where it goes. Makes sense. Okay, so there's a blurb. Got sides, like sketches, historical background. I love this, by the way. Like, including historical background as you go along in the sides, I think is just really cool. Because I care a lot about trivia. In fact, when I was doing my notes for my, my pass exam, I finished it like 4 days ago. I tended to include a lot of asides. Yeah, I do have examples, but like trivia, I call them trivia notes because I do appreciate it. There's nothing that you need to know in order to in them to understand these parts of the book, so you can skip them if you want, but I might be a little sad. Challenges. Don't worry, Robert, I will read them. Each chapter ends with a few exercises. Unlike textbook problem sets, which tend to review material you've already covered, these help learn more. Okay. They force you to step off the guided path and explore on your own. Interesting. Vanquish the challenges and you'll come away with a broad understanding and possibly a few bumps and scrapes. Or skip them. Okay, I'll probably do them if I can. But like, he's saying that he won't go over the solutions in this book, so I guess to that end then it's definitely worth doing it. The challenges often ask you to make changes to the interpreter you're building. You'll want to make a copy of your code. The later chapters that yours are in a pristine state. Okay, I'll see as they come, and I'll decide what to do, because I don't really want to like maintain two different versions of this. Most programming language books are strictly programming language implementation books. They do not talk about designing. Yes, the implementation. Well, I mean, this is using a LOX though, isn't it? Which is already designed. But I guess he can talk about how LOX is designed. Of course. Implementation is fun because it's so precisely defined. We programmers seem to have an affinity for things that are black and white, ones and zeros. Yeah. I know a lot of languages hackers whose careers are based on this. Use like a language stuck under the door, wait a few months, and code and benchmark results come out. I see. So they just do it for fun. I wonder if they ever have any like opinions on what they're making. Personally, I think the world needs only so many implementations of Fortran 77. Ugh. Things like which feature are easy to learn, how to balance innovation and familiarity, what syntax is more readable and to whom. Yeah. To whom? So hopefully your new language doesn't hardcode assumptions by the width of a punch card into its grammar. Yeah. Sick. That's crazy. Is Fortran 77... Like, at what point does Fortran stop being based around punch cards, is what I'm wondering. And, like, shift to bytes. Assuming it... Or, like, bits. Assuming it was... I think it was used on punch cards originally, right? So, like, I wonder what that transition was like. Yeah. And same for, like, C++ and all that, too. All that stuff profoundly affects the success of your language. I want your language to succeed, so I'll end with a design note. I'm no expert on this. I don't know if anyone really is, so take these with a large pinch of salt. That should make them tastier food for thought, which is my main aim. The first interpreter. So we'll write our first interpreter, JLox, in Java. The focus is on concepts. This book uses Java and C, but readers have ported the code to many other languages. If the languages I picked aren't your bag, take a look at those. So I can choose a different one. Yo, C3? That's sick. So people have made it in locks, which I find incredible. C3 speaks to me. This was 2 years ago. Source. Damn, that actually isn't much at all. Are you seeing that? That's including a VM, by the way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 scripts. 1, 2, 3. Look to be specifically VM related. Like opcodes, the VM, of course, and I assume objects are related to that. So that's actually crazy. I mean, maybe the fucking files are massive, but here's the main. Fairly small. We got like a scanner with tokens. It's our tokenizer. This is cool. Quite cool indeed. Many in C, like a lot in C, which is impressive, I must say. C++ is definitely the easier language to do it in, just because of generic programming without macros. But yeah, looks like C++ is quite popular. C#, a lot of C#, which makes sense because the original one's in Java. Ceylon, Clojure, Lisp, only one in Lisp, at least that's here. We've got one in D, that's cool. Crystal, Dart, makes sense because he made it, right? Delphi, Dict2, Elixir, or WorkGenet, whatever. Erlang, Fortran, Jesus Christ. Are you serious? Wow. I don't know Fortran like at all, so I do wonder what it would be like, but that is impressive. Free Pascal, many in Go, Hack, not many in Haskell, surprisingly, considering Haskell is a functional programming language, and those are usually popular for people making languages. Hacks, I don't know that. Inform 6, obviously a lot in Java, JavaScript, Julia, a lot in Kotlin. Lua, Moonbit, Nim. Okay, Nim is interesting. It's a language I haven't really talked about too much because I'm focused on Odin and C3 and Zig. But yep, OCaml, again, less than I thought. Odin, cool. Onyx, Perl, PHP, PowerShell, PHP and PowerShell. A lot in Python. Racket, Rescript, Ruby. Oh my god, Rust has the most by far. Rust has a huge amount. Okay. So I'm hardly being original there. But like, can you blame it when Rust just has such great features for it? Swift. Yeah. TypeScript. Okay. Ren, Exoja, and Zig is another one that comes to mind. I would like to try making a language in Zig. Maybe. So what is Exoja? Cool, very cool. So I would be using Rust, so literally the most popular language for this. But yeah, We'll write this in most clean code. We can to quickly implement the semantics of the language. This will get us comfortable with the basic techniques and also a good understanding of how it's supposed to behave. Java is a great language for this. Unlike C languages, it tends to be less complex machinery hiding under the hood. I guess. And you got static types to see what data structures. Well, yeah, at least it's got static types. Object oriented. Okay, so he's actually supporting object oriented code for this. GCC and LVM written in C++. Okay, little fucking what's the word? Misconception about C++. C++ is not an object-oriented language. It is a language that supports OOP, and Bjarne has talked about this before. GC and LV mentioned C++. Yeah, object-oriented languages are ubiquitous, and tools and compilers for language are ultimately the same language. A compiler reads files in one language, translates them. And, okay, you got a definition of a compiler here. I don't know why the definition for a compiler is on the side. I mean, I guess it's a very brief one. You can implement a compiler in any language, including the same language. It's called self-hosting. Okay. So self-hosting. The act of implementing a programming language in itself. Using itself. You can't compile your compiler using itself yet, but if you have another compiler for your language listed in some other language, you now use that one to compile your compiler once. Now you can use a compiled version of your own compiler to compile future versions of yourself, and you can discard the original one, blah blah. This is called bootstrapping, from the image of pulling stuff up by your own bootstraps. Yep, I'm vaguely familiar with this, but having the formal definition is actually quite useful, or having a formal definition. So bootstrapping is the process of initially implementing your own programming language via another, and then later self-hosting once your own language is functional enough. Functional in the literal sense. So I'll say operational, which also just sounds like a fucking math term. Can't win here, but can't win. Yeah. Again, I don't know why these are asides. These are quite important things, but... And finally, Java is hugely popular for now. Or back then it was. I guess it still is to an extent, and Kotlin is also helping, but I would hope that people are moving away from it. That means there's a good chance you already know it, so there's less for you to learn. I mean, I do know it because I did it this year in university. If you aren't familiar with Java, don't freak out. I try to stick to a fairly minimal subset of it. I use a diamond operator from Java 7. What? So is that what I think it is? Yeah. But what is it? Huh? That's an operator? Okay, bro. That's about as advanced as it goes. If you know other object-oriented languages like C++, C#, you can model through. By the end of part 2, we'll have a simple readable implementation. It's not very fast, but it's correct. However, we are only able to accomplish that by building that on the Java's virtual machines on runtime facilities. Actually, I can't remember what the reviews were for this book. I just know that it was recommended to me. Recommended in general by like Reddit and stuff. Sick. Because it's just a very good guide, I guess. Like, it's definitely a bit outdated, but I think just because the concepts are so timeless, well, at least for now, they've stood the test of time, I should say, then they, like, despite this thing's flaws, it is still worth following, and then you can, like, kind of build up from there. Yeah, so fair enough. There's a little image of bootstrapping, I guess. The second interpreter. In the next part, we'll start all over again, but this time in C. Oh, that would explain why there are so many C implementations. Because I wouldn't expect so many people to be crazy about C. Is it actually C, though? Or C++? I assume it's actually C. So we're making it in Java first and then C. I wonder why. all the way down to the bytes in memory and the code flowing through the CPU. Okay, so it's to get low level. A big reason we're using C is so I can show you things C is particularly good at, but that does mean you need to be pretty comfortable with it. Yeah, you don't have to be the reincarnation of Dennis Ritchie, but you shouldn't be spooked by pointers either. If you aren't there yet, pick up a you can see, blah, blah, blah. I'm sure you come back. C Python is written in C. Is Python itself not just written in C as well? Like initially? Actually, I don't know. How was Python... Which language is Python implemented in? C. So is C Python not just Python? I pronounced the name like C-Locks. Alright, clocks. In our temperature clocks, we are forced to implement for ourselves all the things that we give us for free. Nice. We'll revise our dynamic array and hash table. Jesus Christ. We decide what options are represented in memory and build a garbage collector to reclaim them. Interesting. Very interesting. So maybe what I'll do is I'll do Rust for the first one, and for the second one, I'll do Zig. Or C3. Or Odin. Like, this idea of implementing your own dynamic array is something I haven't really tried yet. And, like, you can do it in C++, but, like, because, you know, vector exists, it exists. In C, you're forced to. And same with, like, hash tables and stuff. Unless you use someone else's library, but still. So, like, it is interesting. So, I wouldn't mind doing that in Zig, since, you know, that's a newer language, or C3, since that's C, but with, I guess, just better ergonomics. I pronounce the name like C-Locks, but you can say it's clocks or even clotch. Clotch is insane. Where you pronounce the X like the Greeks do. How do the Greeks pronounce X? Okay. Ch. It's a raspy, breathy ch or h sound. It's not x. Cherry. Is it like shetty? Or cherry? No, because there'll be sh. Kronos. Tronos. Never mind, it fucking varies. In our scene temperature yep, we decided how to objects represent memory and build a garbage collector. What? We're gonna write your own garbage collector. Is that what you would call a garbage collector? Or just memory management? Our Java implementation was focused on being correct. So now they have the downward turn to being fast. Our C interpreter will contain a compiler that translates locks to an efficient bytecode representation, which it then executes. This is the same technique used by implementations of Lua, blah, blah, blah. I mean, there's 6 languages. It's a compiler book as well. Yeah, I mean, I did think it was just an interpreter book. But okay, we'll also make you a compiler. I mean, it goes to bytecode only, but that is still pretty damn good. I mean, I assume it's bytecode, as in, like, VM bytecode. It is easy to confuse bytecode with machine code, because, you know, you think bytes and machine, like, bits and stuff go together. But no, bytecode is called bytecode because the instructions are a byte each or something like that. Whereas in machine code, that's not true, necessarily. We'll even try our hand at benchmarking and optimization. By the end, we'll have a robust, accurate, fast interpreter for our language, able to keep up with other professional caliber implementations out there. Damn right. Challenges. So these are challenges right here. There are 6 DSLs used in this little system I bubbled together. Well, Markdown is one of them. HTML, CSS, I assume SCSS counts, Markdown, that's 4. I want to assume Dart, C, and Java, more so Dart, is not a DSL. C and Java obviously aren't. God damn. Look at how little code there is. Okay, that's a class. How about the tokenizer, the scanner? Like 240 lines? God damn. I mean, I've done a calculator, and I was surprised at how small it was. And I imagine a programming language isn't that much crazier, but like it's still kind of Wild. I'm excited for this, man. I failed the challenge. I can see CSS. I don't know if I should count SCSS. HTML. So that's 2, maybe 3. Dart, I don't think counts either. Markdown does count. Okay, my voice is cracking. I'm just gonna give up. Get a hello world program written and running in Java. I refuse. But you know what? We're gonna do it in Rust. So, wrong thing. 1 second though. Okay. No ping. So let's go to my projects folder. I'm going to create a new directory called. Actually, let me just make sure I don't already have this. Hold on. I was doing something in Rust already. A calculator, I think. My repos. Sort by last pushed. Well, I did a lot of shit. Yeah, I have my CLI calculator in Rust, but that's it. So I'll probably archive that. Maybe I'll continue it later. I don't know. So locks RS locks. It's probably a good name, as good as any. And then let's go into that. Let's go out of it. Let's delete that directory because I realize I can use cargo instead. Let's cargo new RS locks. Let's cd into RS locks now and list all. Okay, let's open this in NeoVim. Oh look, we already got hello world. Okay, hello interpreter. Hi creative. Okay, my terminal here, cd into that, project / RS locks, and cargo build, or cargo run even, which will build and run. Hello interpreter. Nice. Huge. Should I commit? I'm going to commit to Git as well. I mean, it's already set up, right? So I'll just git add all, git commit, init, and push that to nowhere. So we're going to git remote add, origin, https, github.com/KojoBailey. Before I do that, I need to actually make it. So we'll use gh repo create. I want a new repository on GitHub from scratch. Just open this up. I'm going to call it RS locks. Me. An implementation of locks in Rust following the crafting interpreters book. Public, no readme. Ooh, license. Is there a license on this already? I assume no. There isn't. Yes. Make it GNU. So if anyone wants to use it, they have to make it public. Well, is it a library? No, it's an implementation. So I'll use the GNU public license. How does the Affero actually differ? GNU, Affero difference. Because this one's new, right? Network use is distribution. Must share source code if you distribute the software. Must share source code if you distribute it. Same thing. Network. You can host it on a server and provide it as a web service without sharing the code. Really? So there's a loophole. Fucking hell. So basically, you should use a Pharaoh over GNU now. Damn it. Okay then. I need to update some of my other licenses then. I mean, I know that like people generally won't use my stuff, but you never know, right? And it's a good habit. Yep. Clone it. Do not do that. Instead, we're going to git remote add origin github.com KojoBailey / I'm covering it, but don't worry, rslocks, and then I'm going to git, what's the word, just pull, yeah, pull origin main, and then git push u origin main. Alright, and now if I go to my GitHub, right, /rslocks, there it is. Very cool. Alright, there's a language. There's a webpro even. Do the same thing for C to get back to the pointers. Define a double linked list of holy shit. Define a double linked list of heap allocated strings. Write functions to insert, find, and something. Okay, I don't even know how to do that in C. Low key. I mean, I don't know. I don't fucking C anyway, but well, actually, I guess I do know how to do it. It's more making it safe that I don't know how to do. But that's partially because it's just hard to make it safe. So I'm not gonna do that, but okay. I will get to Zig when I get to it. What's in it, or C3 or I don't know yet. What's in a name? One of the hard challenges writing this book is with the name for the language it implements. A good name satisfies a few criteria. It isn't in use, but I was devastated to find out that Kojo is an existing language. But I mean, to be fair, it's a very cool language. I think it's Indian made, like made in India, and it's used it's used in some places in their education system. I've no idea why they called it Kojo of all languages, like Kojo, the exact spelling of my name. But that is unfortunate, because that would have been a really good name for a language I made, right? Because Kojo is quite an unusual name, and it's quite snappy and rolls off the tongue and easy to remember, right? which I guess is how they. But like, I mean, I don't know why it's called Kojo. Like, I looked at all of their history and stuff, and I couldn't find any link to the name Kojo. So anyway, it isn't in use. Easy to pronounce. Distinct enough to search for. Yeah. Doesn't have negative connotations across a number of cultures. Nimrod. It's called Nimrod before. I wonder why. If your professional name makes it through the gauntlet, keep it. Don't get hung up on trying to find an appellation that captures the quintessence of your language. Okay, something unique. Right. Chapter 2. So, I'm wondering if I should port my notes per chapter. I'm thinking yes, or otherwise it's going to be a Herculean task later on. So let's get this open. Chapter 1. They do have names, right? Yeah, they do. Introduction. I'll probably just write them less loosely, actually. So self-hosting is. By the way, I love how Obsidian converts these symbols. That's very cool. It isn't the code font. It's just a particular feature of Obsidian, which is very nice. I don't know how many symbols it supports, but it does support the single and double arrow, so that's cool. So self-hosting is the acts. I mean, I'll just copy paste my own notes. In fact, I could just do this the whole time. Self-hosting. Awesome. Bootstrapping. a wondering here. Food for thought. I want to call this a wonder. Or a thought. Nah. I'll call it a pondering. I'll call it a wonder. And what I'll do is I'll actually go to my CSS settings here real quick. Appearance, go to my snippets. And I have trivia callout. I'm going to rename this to just callouts, so I can use it for everything. Example is also a callout. So I'll move that here first of all. Huh. Okay. Do this. That means I can delete this. Data callout to be called wonder. As you can see, I already made one for trivia. Just give me a quick color picker here. So wondering, so it'd be like light blue. That's usually the color people use for thoughts for some reason. Let's go with that. Good enough. Oh, okay. Control Shift V. And light bulb. Let's do a thought bubble. I don't know if that will work. Let's reload. Enable callouts. And I don't know how immediate it is. Can I see like a list of Lucide symbols, Lucide icons? Huh? Is it not like a speech bubble? Sure there is, right? There's another word for speech bubble. Speech bubble, official name. Balloon. There's like another word for them though. Okay, I don't know if I want to have to scroll through all of these symbols just to find the one I'm looking for. We got a mind here. I searched for mind and brain didn't come up, so that's a bit annoying. Brain cog, I'll keep that one in mind. It's a potential option. There's bubbles. Cannabis. They got cannabis, but not speech bubble. I can use like a cloud. Not really though. Bunch of folder icons. Git. Wow. Didn't expect that for some reason. I mean, like I'm like 99% sure they have a speech bubble. It just has a name that I'm not familiar with, or I can't think of right now. There's light bulb that I'm also using for something else. Here we go. Message. Message circle dashed. Could do. Okay, so right now I'm on message circle dashed. That's what I'll use if I can't find a thought bubble. Oh, a call out is what I'm thinking of, but we didn't see that in the C section. My God, bruh. A lot of these I do actually recognize from Obsidian, funnily enough. Are these free? They must be. What a good use of my time. I did not find it, much to my surprise. Holy lag. But yeah, it's called message. So message circle dashed is what I'm looking for. So let's do that then. Okay. Decide message circle dashed. Save that. To get it to work, I need to go somewhere. Give it a good refresh, I guess. I think I need to edit it as well, like get rid of it. There we go. Nice. Quit. Close. Is in language truly general purpose? If they, that should be a question mark. Okay. We move on. Whoops. Scintillating. I could give these like a definition box, I suppose. Like that. That looks good actually. Okay, I'm gonna do like a definition box as well. What's a good symbol for that? I'll call it def for define, or for defecate. Appearance, open, new vim. Gonna call outs. Had I missed twice? Go ahead and copy that. Def for define. Make it like orange, like a thesaurus. Oh well, it'll do. Let me actually use my extension here that I got specifically for this. I can copy these, nice. Don't know how I got the perfect amount of 0 blue, but awesome. And is dictionary a symbol? It is. It's called dictionary. No, book A. What's wait? So these ones have aliases. Okay, book A. So it's just a book in general. I like book T. Book type. Alright, close that. Refresh. Nice. Very nice indeed. I mean, they're notes, right? So it's like whatever. They're not gonna be paragraphs anyway. Compilers. You can trust a programmer to turn everything into some fucking abstraction tool thing that I can reuse. So why are all of these just definitions, but like 1 and 2, I guess? Whoopsie, Cavalier. Does my call out thing? No, it doesn't include everything. It's fine. Cool. So that's from the introduction. Let's move on. So it's been 80 minutes. Awesome. I am very slow, but that's okay. A map of the territory. So this is chapter 2. Why didn't I just copy paste it? I don't know. You must have a map no matter how rough, otherwise you wander all over the place. In The Lord of the Rings, I never made anyone go farther than he could on a given day. Okay, we don't want to wander all over the place, so before we set off, let's scan the territory charted by previous language implementers. It will help us understand where we are going and alter the routes. Nice. The implementation is distinct from the language itself, yep. Platonic ideal form. Things like stack, bytecode, and recursive descent are nuts and bolts one particular implementation might use. So that comma is definitely misplaced. Nuts. That's like the anti-Oxford comma. No, there is an Oxford comma. Okay, I'm very confused. Are nuts and bolts one particular implementation might use. From the user's perspective, as long as the resulting contraption faithfully follows the language's specification, it's all implementation detail. Yeah. So language refers to either language or implementation of it. Okay? Unless I think, yeah, okay, fair enough. Yeah, I find fascinating. Even though today's machines are literally 1,000,000 times faster and have orders of magnitude more storage, the way we build programming languages is virtually unchanged. I agree. It's very interesting. Not even actually exams are passed, we'll take a shortcut too, otherwise the original from Mira Grace's first COBOL compiler to JavaScript, whose now it's TypeScript, whose documentation consists entirely of single port edited readme. Sick. Yep, TypeScript, but at some point it was CoffeeScript, wasn't it? Cul-de-sac CS papers and zero citations, and now forgotten implementations only made sense when memory was measured in individual bytes. Huh. What is a cul-de-sac? Short dead end street with only one inlet and outlet. Close of one end, so it is dead end. Oh, I see. I see. Yeah, I changed my mind. I'm gonna just put my notes into Obsidian directly. Cul-de-sac is a dead end street with only one way in or out. I don't know why outlet and inlet has to be the words used, but I visualize the network of paths and implementation may choose as climbing a mountain. Right, as you saw in the thing, right? You start at the bottom with the program as raw source text, such as a string of characters. Each phase analyzes the program and transforms it to some higher level of representation with semantics, what the going to do becomes more apparent. The peak is a bird's eye view of the user's program, which can see what their code means. well, from where you can see what the code means. We begin our descent down the other side of the mountain and just form the highest level representation down to successfully low level forms to get closer and closer to something we know how to make the CPU actually execute. So starting here, we're climbing, tokenizing, parsing, get a syntax tree, and it splits off. You can either do analysis to an IR, or you can transpile to a different language, which then also leads to an IR, and this will just keep on optimizing until eventually it goes either to bytecode or machine code. I mean, doesn't bytecode compile to machine code as well? But I get what it's saying. Yeah, cool. I did actually cover this in university as well, although I was, sorry, I'm covering like a lot of this. But like, I did do this in university already. What? I covered this in university as well, despite already knowing a lot of this. Because when making a calculator, you have to do tokenizing, or like scanning, whatever. Tokenizing is what I call it. Parsing to an AST, you do that as well. And then you do evaluation, which is different from everything else here. I mean, like, it's a form of analysis, I guess. But like, you actually, since it's a calculator, you need to evaluate it. So that's what you would do. But the tokenizing and parsing is largely the same. I mean, they're both things that they have in common, though I imagine with the programming language it's more complex. Let's trace through each of these trails and point out if of interest. var average equals min plus max over 2. So these are tokens, eh? No, sorry, not tokens. These are they're characters with rather horrendous white space, may I add. Scanning. The first step is scanning. Also known, it is weird how this doesn't bother me necessarily. Like, for some reason, like, the lack of white spaces looks more forgivable like this. The first step is scanning, also known as lexing. Every time to repress someone, lexical analysis. That's what we call it in university. They all mean pretty much the same thing. I like lexing because it sounds like something an evil statement would do, but I use scanning because it seems to marginally be more commonplace. A scanner or lexer takes in the linear system of characters and chunks them together into a series of something called more akin to words. Okay. If we're going to use each of these words, it's called a token. I mean, a linear stream, because I guess that's how we type, right? Some tokens are single characters, like this and this. Other ones have been several characters long, like numbers 1, 2, 3, identifier, blah, blah. Some characters in the source file don't actually mean anything. White space is insignificant, and, well, usually. And Copton, by definition, comments, oh my god, are ignored by language, unless you have documentation comments. The scanner usually discards these, leaving a clean sequence of meaningful tokens. Yeah. So, scanning is scanning, also known as lexing or lexical analysis. I do want to practice making notes that aren't like actual paragraphs and more just like notes. I feel like that's clear enough. Although then it's useful to have patterns like AKA this pattern. Should I have like another thing for AKAs, Lexical comes from the Greek root lex, meaning word. Okay, I didn't know that. Trivia, the root lex from Greek, the Greek root lex means word. I put lex in bold there. Parsing. The next step is parsing. Hold on. Yeah. I mean, I'm not gonna include stuff that I already know. It's just like new things I learn is what I'll put in my notes. I'm not going to be the kind of person who just like takes notes on literally every single thing. The next step is parsing. This is where our syntax has a grammar, the ability to compose logical expressions and statements as small parts. What does cornucopia actually mean? It's a card in Plant vs Zombies Heroes, but I don't know what it actually means usually. Also, it's a food thing. Just a symbol of abundance. Konya means horn, copy means abundance. Okay. A parser takes a flat sequence of tokens. Parse tree or abstract syntax tree? So abstract syntax tree, aka parse tree. A lot of bolds in my notes here, I must say. Those are called ASTs. Statement.var, expression of binary, expression of binary, expression of literal. Interesting. Parsing has language history in computer science is closely tied to the AI community. Why is that? Many techniques is used today parsing languages by AI researchers. Is that so? Okay. Oh my god. Huh. A lot of the techniques used in modern day programming language parsing originally stemmed from work in AI to parse human language. That is actually quite cool. I guess that's why we use the word tokens for like generative AI, right? It turns out human languages were too messy for the rigid grammars those parsers could handle, but they were a perfect fit for the simple artificial grammars of programming languages. Alas, we flawed humans still managed to use those simple grammars incorrectly. So the parser's job also includes letting us know when we can do... Dude, that's so funny. But yeah, haha. Static analysis, the first two stages... That's just so funny. The first two stages are pretty similar, so we go static analysis. Right. So analysis is this. This I do not know much about. The first two stages are pretty similar across all implementations. Now the individual characteristics of each language start coming into play. Right. At this point we know the syntactic structure of the code, things like which expressions are nested in which, but we don't know much more than that. I should probably use subheadings. I am. So... scanning, parsing, just like so it's easier to find why I did X note, or like where X note belongs to. Static analysis, analysis. The first two stages are pretty similar. Yeah, in an expression like a plus b, we know we are adding a and b, but we don't know what the names refer to. Are the local variables? Yeah. The first bit of analysis that most languages do is called binding or resolution. Okay. So def binding or resolution is finding where each identifier is defined. Yep, and binding. Oh yeah, and binding the two together, right? Scope of play, we should know the same source code. I know that. If the language is technically typed, this is when we type check. Once you know where A and B declared, we can also figure out their types. Then, if those types don't support being answered, we report a type error. So you get type errors, you get syntax errors. Take a deep breath. We obtain the summit of the mountain and a sweeping view of this program. I guess we have. All the semantic insight that is visible to us for analysis needs to be stored somewhere. There are a few places we can square it away. Often they get stored back as attributes on the syntax tree itself. Hold on, what are we looking at? Semantic insight, okay. Extra fields in the nodes that aren't initialized during parsing but get filled in later. What does that mean? Other times we may store data in lookup table off to the side. Typically the key to this table are identifiers, names of variables, and declarations. In this case, we call it a symbol table, and the values it associates with each key tells us what each the interface refers to. So attributes are on the syntax tree. Okay. The good thing about having source notes is that if I have a definition which I feel might not be quite correct or like not apply so generally, I can still just mention it as if the source is correct, or like correct within its scope, because the note itself is literally tied to the work. So I think that's fine. So you got attribute is defined as an extra field on an AST node that is not initialized in the parsing. Well, that is initialized after the parsing stage. That is filled in later after the parsing stage. Okay. A symbol table, another term that has come up in my uni course, actually. Yeah, the universe, for those wondering, the uni course I'm referring to is the University of Liverpool's Comp 124 Computer Systems, but despite being called that, it goes into like pretty much all the things I'm interested in, from like assembly to Linux and like file managers and processor managers, or process managers, whatever, and network managers. And then for some reason it goes into like programming language grammar and like EBNF notation, and like the process of tokenizing and parsing and lexical analysis is scanning, and code generation and like concurrency as well. Honestly, just a great module for someone like me, and it's a shame that that's literally as deep as we go into a lot of those topics in the entire 3-year course. That is unfortunate. Symbol table associates a key, associates identifiers with what? Variables and declarations. With variable values, or with variables and declarations, let's say. I assume like functions as well. The most powerful bookkeeping tool is to transform the tree. The most powerful bookkeeping tool is to transform the tree into an entirely new data structure that more directly expresses the semantics of the code. That's the next section. Bookkeeping should not be fucking written without a hyphen. That is hard. Everything up to this point is considered the front end of the implementation. Interesting. Very interesting, actually. Wait, so this is static analysis. I mean, yeah, that makes sense, I guess, because like my calculator doesn't have types because everything's just numbers, so there wasn't really much need for static analysis, I think. Then it's a backend. Never mind. The days of yore when front end and back end were co-end, compilers were much simpler. So there's the front end and the middle end. What? Oh no, there is a back end, but there's also a middle end. Great. So besides from the front end and back end of a compiler, there is also the middle end. Coined by who? William Wolf and Co. Who is William Wolf? $1939, goddamn. Okay. Maybe I'll learn more about him over time. Whoopsie daisy. IRs, yep. This is something that is also new to me, and I'm very interested in them. Like the LVM IR, intermediate representations. You can think of the compiler as a pipeline where each stage's job is to organize the data representing the user's code in a way that makes it necessary to implement. So, okay. The backend is considered the final architecture. Yeah, so you can have a modular IR, which I think is cool. In the middle, could maybe stored in some IR that is entirely tied to either the source or destination. Instead, the IR acts as an interface between these two languages. There are a few well-established styles of IRs out there. Hit your search engine of choice and look for control flow graph, static single assessment, continuation passing style, and 3 address code. I'm wondering if a language like Rust didn't have an IR, besides from being harder to develop, would it be faster to compile the language? And if so, how much faster? I do wonder. Like if you skip the IR, because obviously you are, it's like translating from Japanese to Spanish to English. Like it's like translating Japanese to English to Spanish as opposed to just going directly from Japanese to Spanish. I feel like it's like that, but maybe I'm wrong. I should probably write this down. A question. Would languages like Rust compile faster if they skipped the IR? If they skip the IR phase? IR phase? What do I call it? IR step of the pipeline, of the compilation pipeline. And if so, how much faster? That is a genuine question. This SU supports multiple source languages and target platforms with less effort. Yep. Pascal, C, Fortran, Spark. Yep. If you ever wonder how GCC supports so many crazy languages and architectures, like a modular 3 on Motorola 68K, now you know. Mainly Gimple and RTL. Huh, but that's GCC, right? Right, that is GCC. Is this pre... No. When was LLVM? 2003. How about Clang? 07. Damn. A shared intermediate representation reduces that dramatically. You write one front end for each source language, yep, then one back end. There's another big reason we might want to transform the code into a form that makes the semantics more apparent. Optimization. Whoa, was that American spelling? Hold on, Robert Nystrom. It is American. So what's he on about some like hooch? Once we understand what the user's program means, we are free to swap it out with a different program that has the same semantics but implements them more efficiently. We can optimize it. Quotes and folding. Yeah, I mean, like, this is basically what I do in my calculator, right? So if you think about it, my calculator has a lexer, a parser, as an optimizer. Yeah. Lua and CPython generate relatively unoptimized code. Why is that though? What the hell? Constant propagation, common sub-expression elimination, loop invariant code motion, global volume numbering, strength reduction, scalar replacement of aggregates, dead code elimination, and loop unrolling. I mean, I'll look into optimization afterwards. I'm going to do it now when I have nothing to optimize, but constant propagation, I'm assuming is, well, I will look up some of these terms. Is like, okay, my guess is that you just, actually I have no idea. Replaces variables whose values are known constants with the actual constant values compile time. Okay, makes sense. Common subexpression elimination, don't know. Loop invariant code motion, don't know. Global value numbering. That sounds interesting. Yeah. So it just saves the results because like it's the same results. So let's just not reuse the same thing. Strength reduction, don't know that much. Deco elimination is quite obvious, and loop and rolling is also quite obvious. Well, maybe not so obvious, but it's when you just unroll a loop into a sequence of consecutive machine instructions as opposed to jumping around, because jumping is expensive apparently. Code generation. We have applied all of the optimizations we can think of to use this program. The last step is converting code to a form the machine can actually run. So optimization, RIP. I had no notes for you. The last step is converting it to a form the machine. Yep. In other words, generating code or cogen, where code here usually refers to the kind of primitive assembly instructions that CPU runs. This is the back. So this is the back end. Deciding the other side of the mountain from here on out, a representation of the code becomes more and more primitive, like evolution run in reverse, as you get close to something our simple-minded machine can understand. Native code is lightning fast, but generating it is a lot of work. Today's architectures have piles of instructions, complex pipelines, and enough historical baggage to fill a 747's luggage bay. Is that plain? The AAD, ASCII adjust AX before division instruction, lets you perform division, which sounds useful. Except that instruction takes as operands 2 binary coded decimal digits packed into a single 16-bit register. When was the last time you needed BCD on a 16-bit machine? What? Okay, I don't know what that means. Speaking the chips language also means your compiler is tied to a specific... Hold on. Virtual, I assume, means a virtual machine. Yeah. Speaking the chips language also means your compiler is tied to a specific architecture. If your compiler targets x86 machine code, it's not going to run on an ARM device. All the way back to in the 60s, during the Cambrian explosion of computer architectures, the lack of portability was a real obstacle. To get around that, hackers like Martin Richards and Niklas Wirth of BCPL and Pascal fame. I thought the guy who made Pascal was called John Pascal or something. Respectively, made their compilers produce virtual machine code. Instead of instructions for some real chip, they produce code for a hypothetical idealized machine. Oh, wait, so BCPL wasn't compiled? I didn't know that, because I know C is inspired by BCPL, I think. Wirth called this P code for portable, but today we generally call it bytecode because each instruction is often a single byte long. I think B code's a better name, personally. I think bytecode is horribly misleading, or like easy to confuse, but BCPL. Hello world. Jesus Christ. Was BCPL compiled? It wasn't. O code. Alright, object code is another name. That's crazy. Despite inspiring C, BCPL actually used a virtual machine like the JVM. Similar to how Java has its JVM. Yeah. An initial name, an alternative name, an original name for bytecode was P code, portable code, coined by Niklas Wirth. By Pascal's creator, Niklas Wirth. These synthetic instructions are designed to map a little more closely to the language's semantics and not be so tied to the peculiarities of any one computer architecture and its accumulated historical craft. You can think of it like a dense binary encoding of the language's low-level operations. Yeah. Bytecode is so named since its instructions are typically 1 byte. The basic principle here is that the farther down the pipeline you push the architecture specific work, the more of the earlier phases you can share across architectures. There's a tension though. Many optimizations like register allocation. So this is going up. If your compiler produces bytecode, so this is the virtual machine. If your compiler produces bytecode, your work isn't isn't over once that's done. Since there's no chip that speaks that bytecode, it's your job to translate. Again, you have two options. You can write a mini compiler for each target. Yep. But this is simpler than the other one because you get to reuse the rest of the compiler pipeline across all of the machines you support. You're basically using your bytecode as an intermediate representation. Yeah. So bytecode can be thought of as a kind of IR. The basic principle here is that the farther down the pipeline you push architecture-specific work, the more of the earlier phases you can share across architectures. Yeah. So like you still have to implement. So I'll just write this down. Although you still need to implement the machine code translation layer for a virtual machine, the idea is that the benefit is in that you simply need to implement less, right? So that's very straightforward. Let me just move myself down until I actually get to coding. There's a tension though. Many optimizations like register allocation and instruction selection work best when they know the strengths and capabilities of a specific chip. Figuring out which parts of your compiler can be shared and which should be target specific is an art. Okay. Or you can use a virtual machine, a program that emulates a hypothetical chip supporting your virtual architecture at runtime. Running bytecode in a VM is slower than translating to native code because every instruction must be simulated at runtime each time it executes. But you get simplicity and portability, so there's a trade-off. Implement your VM in C, and you can run your language on any platform that has a C compiler. Oh. Interesting. Furthermore, say you implement a virtual machine, just a VM, in C. Now that VM should work on any platform that supports a C compiler. Cool. The term virtual machine also refers to a different kind of abstraction. A system virtual machine emulates an entire hardware platform and operating system in software. Right, yeah, so that's different. That's an SVM, I guess. This is how you play Windows on your Linux machine and how cloud. That's awesome. Linux mentioned in the big 2015 or 2021, and how cloud providers give customers the user experience in controlling their own server without needing to physically allocate. So these are different. Okay. Yeah, I mean, I knew that. It's just good to know, to note. Runtime, where everything falls apart, because everything becomes unpredictable. We have finally hammered the user's program to a form that we can execute. The last step is running it. If you compile it to machine code, we simply tell the operating system to load the executable and off it goes. The VM, right? In both cases, for all but the basest of lowest languages, the basest? Like based? We usually need some services that our language provides while the program is running. I'm sorry, basest? Not like the most basic, is it? Lowest or most extreme degree of something. I guess that. For example, if the language automatically manages memory, we need a garbage collector, a GC, going in order to reclaim unused bits. If our language supports instance of tests, then we need some representation to keep track of the type of each object in execution. Right. So it's like additional software. All this stuff is going at runtime, so it's called appropriately the runtime. In a fully compiled language, the code implementing the runtime gets inserted directly into the resulting executable. Right, so in Go, each compiled application has its own copy of Go's runtime. Okay. So languages may come, well, compiled languages come with a compiled language binaries come packed with that language's runtime, like the Go runtime, which handles garbage collection and whatnot. If the language is embedded, let's put a language. If the language is run inside an interpreter or VM, then the runtime lives there. This is how most implementations of Java, Python, JavaScript work. Okay, shortcuts and alternate routes. That's a long path covering every possible phase you might implement. Many languages do walk the entire route, but there are a few shortcuts and alternate paths. Single pass compilers. Okay. I guess I should restructure this then. This is the parts of a language 2.1. Okay. I did forget this whole thing is actually written in Markdown as well. So scanning, parsing, control, so, option. Yeah. Intermediate, code generation, VM, runtime. Okay. You got shortcuts and alternate routes. That's a long path covering every possible phase you might implement. Many languages do walk the entire route, but there are a few shortcuts and alternate paths. Single pass compilers. Ooh, no syntax tree. Really? Okay. I mean, I probably could have guessed that, but single pass compilers. Single pass compilers do not generate an abstract NAST. These single pass compilers check the design of the language. You have no intermediates, data structures, historical information about the program, and you don't revisit any previous parsed parts of code. That means as soon as you see some expression, you need to know enough to quickly compile it. Yeah, I'm familiar. Syntax translation is a structured technique for building these all-at-once compilers. You associate an action with each piece of the grammar, usually one that generates output code. Yeah. Then whenever the parser matches that chunk of syntax, it executes the action, building up the target code one rule at a time. Yeah, I mean, it's what you pretty much expect, right? But this is the term. Yo, is my font different? Wikipedia. I like it. Yeah, this is different. Is this just me, or is it because I'm on a different laptop than I'm used to? Because I only switched to Linux like not too long ago, and I haven't really used Wikipedia on it yet. A common method of syntax-directed grammar. The language translation is completely driven by the parser. Okay, I don't think I need to define that. Pascal and C were designed with the implementation. They were, which is very surprising. At the time, I mean, well, no, it is surprising that they were able to, like, function. At the time, memory was so precious that a compiler might not even be able to hold an entire source file in memory, much less the whole program. So Pascal and C were originally single pass. Since memory was so precious that it was often unable to even hold a source file, an entire source file to parse. It's why in C, well, to parse once. It's why Pascal's grammar requires type declarations to appear first in a block. It's why in C you can't call a function above the code that defines it unless you have an explicit for declaration that tells the compiler what it needs to know to generate code call. Yeah. Even though C and C++ are no longer single pass, this history is the reason we still need things like forward declarations. I know, it's so peak. She walk interpreters. Ooh. Okay. This is a term I've heard before, but I don't actually know what it means. Some did I skip something? No. Some languages begin executing code right after parsing it to an AST. To run the program, the interpreter traverses a syntax tree one branch and leaf at a time, inviting each node as it goes. This implementation style is common for student projects and little languages, but it's not widely used for general purpose languages since it tends to be slow. Okay. So some people define an interpreter as one that simply traverses an AST and evaluates nodes as it goes, although many would argue for a broader definition. A notable exception is early versions of Ruby, which are tree walkers. Yes, another Ruby VM. Yarv is a bytecode virtual machine. Okay, cool. Transpilers are very cool, and I do wonder how hard it is to write a transpiler. Like, if you wanted to write a C++ transpiler, would you also have to like support all of its grammar, you know, which is quite complex, right? So surely it's not easy to write a transpiler. Writing a complete backend for a language can be a lot of work. If you have some existing generic, I mean, yeah, you can just pile to C++. Ooh, I'm not thinking correctly. No, I'm thinking of like transpiling a C++ similar language to C++, but actually you don't have to do that. You just write a different grammar altogether. Yeah, no, that's fine. Because I would like to make a transpiler at some point that just piles to C++, like in a similar vein to how, you know, Java has Kotlin and JavaScript has TypeScript. You know, C++ isn't so terrible, despite what people say, but I think having just a real, yeah, like a Kotlin to Java, like having something like that to C++ would be really cool. I'm guessing the only reason it doesn't exist yet is that C++ has too many fundamental issues that people don't want to really use it. They'd rather make a new language altogether and remove the technical debt. Whereas a transpiler would more just be like a band-aid, you know, like cover up certain features, maybe like disallow them, change the syntax a bit, remove like the need for forward declarations and stuff. But ultimately it will still be the same language and flawed language. But like even then, you know, like yeah, like it's a band-aid solution, but it would still be interesting to see it. And I mean, I'm sure there are C++ transpilers, and I probably searched for them before, but like there's nothing that is particularly stands out in my memory or in popular culture, or culture like just popular space, whatever. Because like people know Kotlin, people know TypeScript, but I don't think anyone knows a particularly, like generally, I don't think people generally like consensusly, unanimously know a C++ transpiler. Writing a complete backend for a language, I just read that. No. If you have some existing generic IR to target, you could bolt your front end onto that. Otherwise, it seems like you're stuck. But what if you treated some other source language as if it were an IR? Holy yap. The first transcompiler, XLTF86, translated 8080 into 8086. That might seem straightforward, but keep in mind that 8080 was 8-bit and 8086 was 16-bit chip. Interesting. Written by Gary Kildall. Ooh. That's a name I know. One of the first people to recognize the promise of microcomputers, he created PLM and CPM, the first high-level language and OS for them. He made the first OS. Oh, that's why I know his name. Who made the first operating system? Was it him? Okay, I don't know. He was a sea captain, business owner, licensed pilot, and motorcyclist. Wow. A TV host with a Christopherson-esque look. Sported by dashing bearded dudes in the 80s. He took on Bill Gates and, like many, lost before meeting his end in a biker bar under mysterious circumstances. He died too young, but sure as hell lived before he did. Well, someone's a fan. He died... To be fair, he was like 52. Which I mean, it is young. But, you know. At least he didn't die like fucking 30. So, he created the operating system CPM. Which it wasn't the first one. Interesting. Maybe I'll learn more about him in the future. You write your front end for your language, and then the back end, instead of doing all the work to load the semantics, you produce a string of valid source code for some other language that's about as high level as yours. Then you use the existing compilation tools for that language as your escape route off the mountain, and down to something you can execute. Cool. I do wonder why more languages don't do this. I guess because you don't need to. And like IR exists, right? Like the LVM IR exists. Which I guess is another reason people don't actually transpile to C++. Like at that point, just transpile to fucking LLVM. Because like that's written in C++, right? So I wonder if the reason that C++ doesn't have a popular transpiled language like Kotlin is to Java or TypeScript is to JavaScript is that the LLVM IR is already written in and syntactically not too dissimilar from C++ anyway. That would make sense to me. Like if you look at LVM IR, oh, I know this guy. I think I have this bookmarked actually. I do. Yeah, I do. I've actually been meaning to read this, so I'll probably give it a look at some time in the future. Pub FN Square. To be fair, actually looks more Rust-like. But like, yeah, like why would you not want to just write this? You know, it's cool. You write your front of okay, they used to call this a source-to-source compiler or transcompiler. After the rise of languages that compile to JavaScript in order to run in the browser, yeah, because they have to, they've affected the hipsters sub-request transpiler. Like, it's so weird how browsers can't just, like, fucking be more efficient than JavaScript. But, hey, these are cool. I mean, I know that, like, WebAssembly exists, but, like, doesn't WebAssembly compile to JavaScript? Does WebAssembly use JavaScript? Or is it like a different standard? I don't know. Well, another, yeah, so transpiler, aka source to source compiler. That's a term I've used, like I've heard like once or twice. Transpiler. While the first transpiler translated one ASM to another, today most transpilers work on high-level languages. After the viral spread of Unix to machines, various and sundry. Several different various or miscellaneous things. Okay. There began a long tradition of compilers that produced C as their output language. C compilers were available everywhere Unix was and produced efficient code. Yeah, Linux also supports C out of the box. Or like it usually comes packaged with GCC. In fact, I think my Linux installation even came with Clang as well, which is cool. I mean, is it cool? I don't know, but like it meant that I didn't have to install it. It's just I guess it's just interesting that they decided to do that. C compilers were available everywhere Unix was and produced efficient code, so targeting C was a good way to get your language running on a lot of architectures. Right. Yeah, that makes sense. And like, again, like it's another reason that I guess bootstrapping is so good. Maybe. Web browsers are the machines of today, and the machine code is JavaScript. So yeah, so these days it seems almost every language out there has a compiler that targets JS, since that's the main way to get your code running in a browser. Yeah, look, CoffeeScript. CoffeeScript, JavaScript extensions, Ruby and Python compile to JavaScript. What the hell? Well, they can, I mean. Erlang, Elixir, Gleam, Perl, Java, Scala, C#, C++. I guess every language can to like turn on the web, right? And there's also WebAssembly. Yeah, I really have to wonder, or even just a question: why does JavaScript have to be the machine code of the web? Why can't a more efficient, performant alternative be created? Or is this what WASM is? Because I don't think WASM is separate. I think it does compile to JavaScript, but I may be wrong. The front end scanner and parser of transpiler looks like other compilers. Then, sorry, JS used to be the only way to execute code in a browser. Thanks to WebAssembly, compilers may now have a second low-level language they can target that runs on the web. Oh, okay. So I guess WebAssembly is actually that thing. Because like all you need is your browsers to just agree on a new standard. And sure enough, well, I mean, I would expect that browsers would want this to be happen, and then sure enough, WebAssembly exists, so... Yeah, I do want to look into WebAssembly. I wonder how fast it is compared to machine code as well. You know, like system level code. Because like if it's fast, then honestly, it's quite appealing for creating web apps over systems apps, or like at least like compiling for both, right? And it's interesting. Some people call like browsers like basically a OS within an OS, and I do have to agree. It does feel like that. Especially now as we get WebAssembly. The front-end scanner and parser of transpiler looks like other compilers. Then if the source language is only a simple syntactic skin over the target language, it may skip analysis entirely and go straight to outputting the analogous syntax in the destination language. It's true. That doesn't mean it's faster though, obviously, because it has to translate, and then that one has to compile. If the two languages are more semantically different, you'll see more of the typical phases of a full compiler, including analysis and possibly even optimization. Then when it comes to code generation, instead of outputting some binary language like machine code, you produce a string of grammatically correct sourced code in the target language. Either way, you then run that resulting code through the output language just existing compilation pipeline, and you're good to go. Then you have JIT. This last one has less of a shortcut and more dangerous alpine scramble, best reserved for experts. But is that not what VMs do? Okay. Shout out Alpine. High mountains over the slopes above the timberland. Oh, I see. The fastest way to execute code is by compiling it to machine code, but you might not know what architecture your end user's machine supports. What to do? Well, yeah, C# uses this for Unity. You can do the same thing that Hotspot Java Virtual Machine, well, you can. Microsoft's Common Language Runtime and most JavaScript interpreters do. On the end user's machine, when the program is loaded, either from source, in the case of JS, or platform-independent bytecode, you compile it to native code for the architecture the computer supports. Naturally enough, this is called JIT. The more sophisticated JITs inserting profile hooks into the generated code to see the most sophisticated JITs insert profiling hooks into the generated code to see which regions are most performance critical and what kind of data is flowing through them. And they recompile hotspots. And there's a hotspot JVM. So a JVM, or sorry, a JIT compiler. Is it saying like initially it will run fairly slowly, like relatively slowly, but then over time, as it's still running, like on runtime, it can become more performant over time. Is that what it's saying? This is just in time compilation. Is it saying that a JIT compiled program starts out relatively slow, but becomes more performant over time as hotspots are identified and optimized? Performant is a word. Hotspots is also a word. Jesus Christ! Why is this spell checker for Obsidian so shit? Side note. Compilers and interpreters. Hey, look, that's us. Alright, so it's like, what's the distinction? I guess compilers and interpreters. Now that I've such a head with the dictionaries with a programming language jargon, we can finally address a question that's plagued Kojo since time immemorial. That is a cool phrase. What's the difference between a compiler and an interpreter? It turns out it's like asking the difference between a fruit and a vegetable. It's a botanical term, and a vegetable is culinary. Really? I thought both were botanical. One does not strictly imply the negation of the other. There are fruits that aren't vegetables, and vegetables that aren't fruits. But also, what the fuck? Okay. Unlike fruits, vegetables are actually not a botanical category. They are culinary. Meaning there is actually overlap between the two groups, such that some foods are both fruits and vegetables. That is insane. That is the most shocking thing I've learned from this so far. Peanuts, which are not even nuts, are hilarious, and cereals like wheat are actually fruits. What the fuck? But I got this drawing wrong. What can I say? I'm a software engineer, not a botanist. I should probably raise the little peanut guy, but he's so cute that I can't bear to. Now, pine nuts, on the other hand, are plant-based foods that are neither fruits nor vegetables, at least as far as I can tell. What? So tomatoes are fruits and vegetables? Tomatoes are both, for instance. That is insane. A tomato is both a fruit and a vegetable. I feel like I vaguely knew that, but at the same time, not really. But then what's I vaguely know the fruit definition, which is like seeds, whatever. But then what's the culinary definition? Why is this what grabs my interest? In that case, what is the culinary definition? Seeing as fruit is more or less to do with seeds. Okay. Right, so compiling is an implementation technique that involves translating a source language to another. Okay. When you say a language implementation is a compiler, we mean to translate source code to some other form but doesn't execute it. Yeah. So like in that sense, and if you have something that compiles the bytecode, that is a compiler, right? But usually the interpreter will just it still has to compile, but I guess the idea is that an interpreter isn't machine code. I guess that's where I would draw the line. Like a JVM, or sorry, a VM, yes, it is compiled to, but the VM itself then has to interpret, right? So in that case, the language is both compiled and interpreted. So really you have interpreted languages and not interpreted languages, right? The user takes resulting output and it themselves. Conversely, when we say an implementation is an interpreter, we mean it takes in source code and executes it immediately. Yeah, typically, but that's not true necessarily. Like apples and oranges, some implementations are clearly compilers and not interpreters. GCC and Clang take your C code and compile it. An end user, blah blah blah. In older versions of Matz's canonical implementation of Ruby, the user ran Ruby from source. Right? But what of C Python? Good question. Yeah, bytecode. From the user's perspective, it's an interpreter, but they run their program from source. But look under the skin, and there's some compiling going on. The answer is that it is both. CPython is an interpreter and it has a compiler. In practice, most scripting languages work this way, as you can see. Yeah, fair enough. Interestingly, JLOCs will be purely interpreted, but CLOCs will be both. The Go tool is even more of a horticultural curiosity. If you run go build, it compiles your Go source code to machine code and stops. Go run will do that, and then immediately execute the generated executable. So Go is a compiler, and it's an interpreter. Huh? Is that what Go does? Wait, but Go still produces an executable, right? Like how cargo run, I assume, will build and then run, as opposed to just run off nothing. So Java C is a compiler, GCC, TypeScript, transpiler, fair enough. CoffeeScript, Rust, and Clang. Rust mentioned? Holy fuck. C#, Haskell, CPython, Yarv, Lua. Lua's partially compiled? I don't understand Lua at all, honestly. Like I do like Python, like you can just write Python, but like I've only really ever seen Lua be embedded. But like if you embed it, is that really a language, or is it just like it's like a scripting front end that you can like define the back end for? I don't really understand how that works, but I assume this is Lua, like Lua the language, the standalone language, which also must exist. CLOCs, Go, Guile, Scheme, okay, Scala, V8, something JavaScript thing, and PHP 4. Yeah, I didn't know that Lua. Okay, whatever. And then MRI, JLOCs, and PHP 3. So PHP 4 actually switched to also being partially compiled, which is interesting. Okay, our journey. That's a lot to take in. Don't worry. This isn't just the parts you're expected to understand. All these pieces and parts. I just want you to know that they should. Okay, this map should serve well. For now, it's time for your own journey to begin. From here on out, all you need to focus on is the path in front of you. Henceforth, I promise to tone down the whole mountain metaphor thing. Okay, so we got some challenges here. Pick an open source implementation of a language you like. Download the source code and poke around in it. Try to find the code that increments the scanner and parser, or the handwritten or generated using tools like Lex and Yak. Fuck it. Let's go ahead right now to the GC. No, fuck that. Let's do it for the Clang C++ compiler source. Please be on GitHub. It is. For GCC, you have to clone it yourself, and I am not doing all that. Not now. Oh my god, look at how much there is. So if I look at this language, let's search for token. Clang/lib/lex. Is that where it is? So Clang. Lib? AST! Lex! Oh my god, it's here. There's so many. Oh my days. Token Lexer! So is that it? Why is there no syntax highlighting? Even though it's a CPP file. What is going on, GitHub? Oh my god. And it uses actual classes. Yo! I mean, it's like 1,200 lines of code, but I mean, comments I guess take up quite a bit of it. Awesome. Yeah, definitely big. Too much for me right now. But what are these challenges, bro? I don't see any LOY files though. Just-in-time compilation tends to be the fastest way to implement dynamically typed languages, but not all of them use it. What reasons are there to not JIT? Statically typed languages. Most libs implementations like Kojo C also contain an interpreter that lets them execute Lisp code on the fly as well. Because maybe you'd want access to the dynamic language, you know? Alright, next chapter. Right, so I think this is when we start actually making the language. So I'm going to end the video there because I need to shit. And I might continue with something else before coming back to this. But it's very cool. Very intriguing. I look forward to getting into the actual process of implementing this language. I'm quite excited. How many chapters are there in total, actually? Can I see like an outline of the entire book? If I just zoom out here. Yeah. So, okay, never mind. The Lux language is still part of the welcome thing. Oh well. I'll just group that in. We got scanning, representing code, parsing sessions, evaluation. Then for the other one, for the bytecode, we have all this other stuff. So the actual interpreter shouldn't take that long. It says it's like 9 chapters, 10 chapters, whereas this one is a lot longer, maybe 16, 17 chapters. So cool. But yeah, there you go. That was an introduction to crafting interpreters and compilers. I again look forward to doing that. Yeah. I guess after I finish this, assuming I do finish it, but I think I will probably try creating my own language, I guess. Yeah, maybe. Maybe. We'll see. But yeah, that's the video. Subscribe to see more progress on this. In fact, I do have a playlist, I think, for like this project. It already includes my compiler stuff because that counts, right, for me loading this. So check that out too, I guess, if you want to see more videos on this matter. My progression as someone learning how to implement programming languages.